He's like 5'5". Hopefully he will be, yeah. Alright, so 3.1, solving systems using tables and graphs, and your graphing calculator. First example, we're going to solve by graphing by hand. So we have 2x minus y equals -1 as your first equation. Second equation is going to be 1/2x minus 2 equals y. Okay, so this second equation here, all you need to do is write it so the y's on the left. If you can graph it with this other step on the left, that's fine. But sometimes it helps you guys if it looks like slope-intercept form. So you can just switch the sides on the equal side. And if I'm taking this math class, I would always do this. Anything that reduces your confusion level, and if it looks like a regular old equation, absolutely write it like that. If you totally get it, you don't have to, but if anything that reduces confusion level is good. What do I have to do to that equation? On the left, Elijah. What? Divide the 2. Nope. Shannon. Minus 2x. Right? Because we want to make it look like slope-intercept form, like this equation over here. So subtract 2x from both sides, and we get -y equals -2x minus 1. I'm writing the x term first, so it looks like slope-intercept form. Hayden, what do we do next? Louder. Divide by -1. Fantastic. So when I was grading your test, I saw a lot of people do this. And I can't tell you how many times you make mistakes doing that. Because what you have to do is divide this side and this side. And most often you forget one of them. So instead of writing it like this, write it as the 2 fractions with the divide by -1. Okay? Because then you're less likely to make an error. So what we get here is y equals 2x plus 1. Right? Negative cancel make positive. Anna? Yeah. Multiply and divide by -1, you get the same thing. That'll make you really happy, right? Okay, Elijah? I did. Okay, so now we're going to graph these two. We have 2x plus 1 and 1/2x minus 2. So we're going to graph that thing. Yep, same graph for both lines. Team, where do I start to graph? First one. Good. So y equals mx plus c, that's what we're thinking about. So I'm going to start on the y-axis at +1. So notice, I was thinking about this when I was teaching my secondary altitude class. You guys will say something and then I'll say it in the way I want you to say it. So Kane said start at 1 and I said start at 1 on the y-axis, right? I want you to think about those things all the time. I'm trying to just correct and say it better than the way you say it. So what do I do for the slope, Kendall? I don't know which way it's over. And Kendall, I can also go down to left one, great. So if you don't get that, you can always put the 2 over 1, right? So we go up to right 1 or down to left 1. So we're going to graph that line now. Really important when you're doing this homework that you graph accurately. On a test or a quiz, I will give you a little grid to graph it on, but when you're doing homework, you want to have graph paper to do these. Emma?
Where did you get going up to? Or going up to?
Up to the right 1. And I can also make both these negative, right? So I can go down to left 1. Because what happens with 2 negatives? They cancel and make positive, right? So I can go up to right 1 or down to left 1. The only reason I emphasize that all the time is because sometimes your y-intercept will be like 8, and it'll be up 4, right 1, and you run out of room on your graph, so I just want you to know you can go down 4, left 1 as well. All right, graphing the second line. Sam, what do we do? Yes, indeed. Start at -2 on the y-axis. Up 1, right 2. You can also go down 1, left 2. So you're looking for the intersection of these 2 lines, okay? So we're going to graph that. And where do those 2 lines cross, Amanda Gailey? Left 2, down 3. So -2, comma 3. Julianne, you had a question? So they won't always cross. We'll talk about that in a sec. Yep. Perfect. Right, so if I plug this in, I'll plug it into the top equation. We have 3 equals 2 times -2 plus 1. That means this side should equal 3. It does. Does it? It should be -3. Oh, there we go. That's confusing for a moment. So yes, it does. Right, because we get -4 here plus 1, which is -3. So indeed, it does equal -3. So what we're doing is figuring out the x and y value that will make each equation true. Okay? So that's that. So when the lines cross, we have one solution. One solution, and because it's one solution, it's independent. And it's consistent. So if we have a graph like this, where we have 2 parallel lines, then there's no solution, right? Because the lines never cross. And it's inconsistent. So you have to know this independent, inconsistent, consistent thing. Nope. The consistent thing, the way I view it, is like if it has a solution, it's consistent. If it doesn't have a solution, it's inconsistent. You think about your crazy friends who are behaviorally inconsistent, right? There's no solution to that behavior. They're just weird. Weird's good though. But, you know. So the last one we have is when we have the same line. So we graph it, and we have two lines that look right on top of one another. And in that case, it is dependent. There are also infinitely many solutions. Nope, because you'd have to make it one gigantic list that goes on forever. And it's consistent. Right, because we have solution here, 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 right, forever. You could slice the line with a microscope and come up with a million more solutions, right? So infinitely many, dependent, and consistent. And you just got to memorize those. Whenever I have to memorize something like that, I try to make sense of the word so I can remember it. And then you're not really memorizing anymore, you just understand it. So it makes sense because they're infinite solutions, but it's dependent. I think of independent as one solution, dependent as many. Stay consistent because there is a solution, whereas the parallel lines are inconsistent because there's no solution. Okay, the first one up here, when the lines cross, makes sense that it's independent because there's only one solution. You're an independent person, you're off by yourself, right? You don't need the help of others. So independent, one solution, consistent, it just makes sense because there is a solution. So that's kind of how I remember one from the other. Okay, next we have story problem. So I go over the method of story problems every single time we have a story problem. The method is, and I'll illustrate and hopefully you'll be able to remember it quickly. First thing you do is you read the story problem once without writing anything down. That's important. It's a step that I used to skip when I was in high school and college because I feel like I always know how to do them or I could always figure it out. So I just wanted to start writing stuff down. And then I would screw up because I wouldn't answer the question. So you want to read it once, don't write anything down. Read it the second time, highlighting or underlining important information. Read it the third, or write the equation, step 3. Solve the equation, step 4. Make sure you answered the question, step 5. Okay, so I'm going to read it. I would not write this whole thing down because it's kind of a waste of time. I'd write camera 1, $89.98, camera 2, 24 cents a pick. Camera 2, $124.98, 9 cents a pick. And then I would write something abbreviated about this question. We want to figure out when is the cost going to be the same. After how many pictures do I have to take? Is the cost the same? And then they also want to know what that cost is. So I'll give you a chance to write some of that stuff down. And then we've got the beauty of the story problem. It's so sneaky with this laptop part, isn't it? You could close that. You don't need that. So this, well, first of all, what's some important information, Jessica? Right. I had somebody in second period say all the numbers. That's pretty accurate. Can't argue with that, right? So all the numbers. We know we have 2 cameras. We know we have different print costs for each kind of camera. So we're going to make 2 equations with that. So This is what's called a break-even problem because we want to figure out when are the two costs equal. So you can just write the equations without a y because we don't have to graph this. We're just doing math to answer it. So what's the first camera cost? Brady. So I'm going to just make it nice and organized. Camera 1 cost $89.98. Plus how much per print?
24 cents.
24 cents. So that's camera 1's cost and cost per print. Camera 2, how much does camera 2 cost? Roughly. 124.48. And how much is the print? So plus 0.09x. So if you have trouble figuring out which number the variable goes with, anytime you see words like each photo cost, right, that means you could have 2 photos, 3 photos, 1,000,000 photos. That's where the variable goes. When you hear words like each or per, that's where the variable goes. Okay? And then the camera cost is one time, right? We're not going to take one picture and buy a new camera. That's kind of stupid. It would be really expensive too, right? So you buy the camera and then you're going to take multiple pics. And the cost, like on a digital camera, right, that's like your toner and the fancy printer paper, right? 9 cents per copy you make. Copley, how do I solve this? Variables on both sides. I want to get my variables on one side. What do I do? I'm going to minus the 0.09 so I don't have negative numbers, but squeeze the 0 in there. So minus 0.09. You could subtract, Copley said subtract the 24. You can absolutely do it that way. But again, I always try to teach you the way that will reduce the amount of mistakes you could make. So I like to subtract that 0.09. So what we have left is 89.98 plus 0.15x equals 124.48. Ricardo, what do I do next? Minus 89.98, perfect. So we get 0.15x equals, what is that? What do you get? 34.5. Can you do the next one too? Then we're going to divide by 0.15. Okay, thank you. So x equals 230 what? Nope. Pictures. So I wrote the equations, right? Step 3, solve for x. Step 4. Step 5, make sure you answered the question, because we've answered part of the question, but not all of the question. So I'm going to go back up and look at that last question. After how many photos will the overall cost of the cameras be the same? Did I answer that question? Right, 230 photos. So what will that cost be? What do I do to figure out what that cost is going to be? Stephanie? Yeah, I can plug it into either side. I can plug it into this side or this side. Why? Why can I plug it into either side? Right, they're both going to equal the same. Because I just figured out how many pictures I have to take for the two equations to equal one another. That's 230. So it doesn't matter which one I plug it in. If you're paranoid on the test, and you want to plug it into both sides to make sure you get the same number, not a bad idea. You should get the same number, so it doesn't matter. So let's plug it into the 8998 side. So I have 89.98 plus 0.24 times 230. Then what'd you get? 145.18. 145.18. So how much will it cost you for the two, with the print cost and the initial cost of the camera, for the equations to be the same? It'll cost you $145.18. That's what that all means. So that's a break-even problem. Absolutely expect to see that on the quiz. Break-even problem, no question that'll be on the quiz. So in your different colored writing implement, next to that example, you're writing on quiz. And if it's on the quiz, it's probably going to be on the test too. Because these are important problems to know how to do, okay? You can do it in your calculator. So the only disadvantage to just doing it in your calculator and not writing this down is what? You messed up. You missed that entirely. Because I don't know what you did to mess up. So I would just, I'll take more points off. Just, I always think like partial credit is your friend. So I wrote that actually on top of my ALS 1 text I gave today. Monday test, brutal, right? What can you do? But if you show this step and you screw up this answer, I'll give you most of the points, right? Because that means you just hit like a 5 here instead of a 0 or something to get the wrong answer. So showing that step gives you more partial credit even if your answer is wrong. Okay? Alright, next one. This is easy. So you want to bust out your calculator and you want to hit, stat edit. We're going to enter in this to list 1, 2, and 3. See? It's going to be. I'm almost done writing them. I haven't quite finished yet. But those are all the button pushes. Okay, so we're going to enter in. I'll just show you on my calculator so you can enter it all in. You still don't have one? Got to bring your calculator. That's not going to work for you. That's not a graphing calculator. It won't work. I'm out. I only have 6 to learn. Or 7, I think I have. So enter those in. You got to make sure your calculator says list 1, 2, and 3. And I figured out a better way to plug the equation into the y equals. It's easier, less buttons to push. That's why it's beneficial you guys are the second Algebra 2 class I teach. Always better. Now my Period 2 Algebra 2 students that listen to this will be all done. Still good. Just gets better. So, right, we had year 2005, 2006, 2007, 8, 9, and 10. So, instead of writing 2000, I just did the last digit of the year. You can do that. It's legal. So we're going to do linear regressions with 2 separate lists. That's what we're working on. Does everybody have that in? Does anyone not have it in? Okay, Andrew, you need a little more time. Now you put the pressure on you, right?
No.
Alright, good. Anybody else need a second to plug it in? You Casio people? Anybody have a Casio in here? Best of luck. No idea how to do that. Okay, so now we're going to go, you hit y equals, clear out whatever's in your y equals. If you want to see the points, you can go up to plot 1, hit enter, and go up to plot 2 and hit enter. It doesn't really matter, so I'm not going to turn that on. Yeah, you don't need to. Okay, so we're going to go back to the home screen. To do that, you hit second mode. Mode's right next to second. And then we're going to do a linear regression. So we're going to go stat, over to calc. Number 4 is linear regression. So if your calculator looks like this is what you're going to do. And if your calculator, how many people have a little list of things where it's like, what is state X list, Y list? And then, okay, so where you see X list, you guys are going to go second L1. For you, yeah. For those of you that your calculator looks like this, you're just going to hit second L1 as well. Then we're going to hit comma. Comma's right above the 7. And then we're going to go second list 2. So your Y list, and those of you that have the 4 things, what is it? X list, Y list, and what else? Store regression equation. So we don't need the frequency list. You don't need a comma if you have if yours is like that. Okay. You're just changing it to list 1, list 2. And then where it says, thank you, store regression equation, you guys are going to put in Y1. This is how you do it. So if you have the calculator that looks like this, you need another comma. So for those of you that have the list where it says store regression equation, you want to do this. So vars, y vars, function, y1. So you go vars, y vars, function, y1. Vars, y vars, function. You can always go second. Yeah. Okay, now go. No, you're good. Already got this one with two. Go bars. No, you don't need it on my phone. Now go. Okay. Go bars. Y bars. Function. Y1. Now you get. Now here's like.
They're all
So your graph should go down to calculate how we are right here. Bars, Y bars.
Oh.
So we're going to plug it in. So go down, those of you that have the list of things, go down to calculate. And then it'll show you should have an equation that looks like this. Negative 3.9. And then the B is 651. And then if you hit y equals, that equation is in there already. So that's the benefit of doing that. Okay, now we're going to graph it with the list 1 and list 3. Question? You can put it into the Y1. So the bars, Y bars, you can enter. There's your equation. You get Y equals. Hold on. Back to if you want to put in the Y1, the second enter, and then you can go and then you enter, that's your equation, and there you didn't push the Y1 part. Comma, bars, Yep. We're going to put the other one in there. I know you have a minute and a half, but I don't care. We can turn it in tomorrow. Here's how you do the next one. You don't need to hit clear, it doesn't matter. You can hit clear, it'll look just like mine. So we're going to go stat over to calc, linear regression again. So we're going to use list 1, list 3, and then Y2. Okay. So your homework's on the board. Homework's on the board. It'll be on the website too if you didn't have a chance to write it down. Turn and return the calculator for you. Tomorrow after school?
Yeah.
Yep, absolutely. Crazy. A lot of calculator to remember, huh?
Will you put it over tomorrow?
Yeah, you can turn it in tomorrow.